Myself, Dr. Shivankar Samanto, Assistant Professor of Vidhannagar College, wish to present my video regarding the NET question solution 2023 and JAM guidelines. Now, we wish to present my heterocyclic related questions, that is the indoles containing substituents with that of the trimethyl amine derivatives. That is these derivatives is mainly from via the Billismar-Hack type of the complexation reactions, and then when treated with that of the sodium cyanide, it formed that of the cyanide derivatives. The problem given in the NET questions is that the cyanide minus can directly attack to that of the NME3 by the leaving of the NME3 minus, and via the simple addition elimination reaction or elimination addition reactions. These problems is very simple questions, and this mechanism is related for that problem is that in the first cases the nitrogen lone pair is conjugated with that of the pi electrons and leave that of the NME3 ions, and then this NME3 neutral species is leave from that of the species, and then this 2 substrate is produced, and this 2 substrate on addition by the CN minus gives that of the our desired giving derivatives. And the mechanism is that the reaction is the elimination followed by the addition reactions, and this compound is mainly formed by the addition of the dialkyl amines with that of the formaldehyde produces the cations, and then these cations is added to that of the nucleophilic substitution reaction followed by that of the aromatization give the product, and then this product is on methylation on treated with sodium cyanide produces the our given problem products, and this product is mainly formed by the addition elimination reaction, but the simple substitution reaction is not take place as the strong pi electron resonance prevent simple substitution reaction. That is, after the leaving from the system, a carbocation is formed, and then this carbocation is stabilized by the nitrogen lone pair electronic resonance, and hence it prevents the simple SN2 reaction. So the answer for this given problem is that elimination followed by the nucleophilic addition reactions. Now we go to that of the interesting topic from Clayden is that this compound is coming from that of the Billismar-Hack type formylation or formylation complex compounds, and the first step is that is the Mannich reaction. Here the Mannich reaction produces the Mannich salt, and this Mannich salt is added by the pi electron of the aromatic rings and produces the substituent dialkyl substituted amine derivatives, and then this dialkyl substituted amine derivatives on treatment with that of the sodium cyanide or by the addition elimination mechanism produces the desired product, cyanide containing desired products. These cyanide containing desired products has capability with that of the flip type reaction, that is the 3+2 cycloaddition reaction, and produces the 3+2 cycloaddition product, that is a tetrazoleum substituted derivatives. Another interesting problem regarding the heterocyclic chemistry is that the sclambining of the isotopic labeling carbon atoms via the simple Lewis acid base complex reactions. Here the indoles derivatives has greater capability by the pi electron attack by the 3 centers and produces a pyro type of compounds, and then this pyro compound has capability for the alkyl migration by the 2 modes, and hence we get the 50:50% product with that of the carbazole substituted derivatives. And this another interesting problem from the Clayden books is that the different type of the basicity orders of the cyclic amine derivatives. From the cyclic amine derivatives, it has been shows that the pK value of the piperidine and typical amines and the pyridines is that the aliphatic amines has the higher pK value, hence it shows the higher basicity compared to that of the pyridine, and typically in case of that, the sp2 hybridized nitrogen atom is more electronegative, so it has lesser tendency to donate lone pair to that of the protons, and the aromatic pyridines has lower basic character compared to that of the typical imines, that is it has pK value 5.5, and this is due to that of the nitrogen lone pair is more S character and hence lesser tendency to donate lone pairs. Another interesting problem regarding the halogenations of the benzenes is that in case of we know that the benzene can be halogenated by the addition of the bromine molecules, but here the interesting is that the pyridine added of the bromine produces the pyridinium bromide compounds, and this pyridinium bromide compound can help to easy attacked by that of the bromine atoms and produces the electrophilic substituted product, and this electrophilic substituted product gives that of the substituted derivative of the bromo derivatives. And another problem is that the different basic character of the pyrrole derivative of different positions, that is the pyrrole can be protonated either on the nitrogen atom or in the C2 position or in the C3 position, but the basicity of the C2 nitrogen lone pair is very less compared to that of the C2 or C3. The order for the H plus addition to C2 position is greater basic character compared to that of the C3 compared to that of the nitrogens. And another interesting problem regarding synthetic chemistry is that here the alkylation can take place in presence of the butyl lithiums with that of the benzyl bromides, produces the furan substituted derivatives, and these furan substituted derivatives has been hydrolyzed to give that of the 1,4 dicarbonyl compounds, and this 1,4 dicarbonyl compound undergoes aldol condensation to give that of the cyclopentene derivatives. And these problems which come from that of the net examinations, that is the synthesis of Catarolak derivatives, and these Catarolak derivatives can be synthesized by the simple addition and substitution reactions, that is here the acyl groups containing the phenyl rings is more electrophilic, more electrophile to that of the pyrrole rings, and hence it can easily add and eliminate it to give the Catarolak derivatives. Now we go to the radical chemistry. In the interesting problem is coming in the NET examination 2023. Here the different type of the methyl and cyclohexyl radicals is added to that of the acryl and nitrile derivatives. The rate of these acryl and nitrile derivatives is mainly explained by the homolumo interactions, that is the single occupied molecular orbital. Actually, these alkyl radicals are nucleophilic in nature, so it has greater capability to that of the electron deficient center for the addition. For the electron density for the cyclohexane ring is greater compared to that of the ethyl and the methyl rings, and hence the cyclohexyl rings has higher sumo energy compared to that of the ethyl and the methyl derivatives. And this sumo energy means this cyclohexyl the energy required for the homolumo interaction for the cycloalkyl derivatives is lower compared to that of the ethyl and the methyl derivatives, and hence the rate for the addition to that of the acrylonitrile is that C is greater than B is greater than A. Now we go to that of the next questions, that is the stereoselective addition of the halogen atom in presence of the photochemical conditions. Here it has been shown that in presence of the chlorine photochemical under H it gives that of the primary alkyl halide with that of the secondary alkyl halides, but in case of the isobutane the chlorination take place is less in the tertiary butyl substituent compared to that of the primary. That is the primary substituent has primary carbon has greater capability for the halogenation compared to that of the tertiary carbon atoms, and this rate can be explained by their relative product ratio and also that is the hydrogen containing ratio. In case of the substrate, if we compare that, here the 9 hydrogen atom is present in the isobutane structures, and hence our primary type 9 hydrogen atoms, and 3 degree type only 1 hydrogen atom. And if we compare their rate, and we shows that the product ratio is that of the 5:1. Here the relative rate can be calculated from this product ratio. Now we going to that of the halogenation of the chlorine with that of the isobutane structures, and it has been shown that the reaction is exothermic in nature, that is the product is more stable than the reactant. And from the Hammond postulate, it has been shown that the transition state is resembles to side to that of the reactant compared to that of the product. If we go to that of the bromination reaction, in case of the bromination reaction, the reaction is endothermic in nature, that is according to the Hammond postulate, the product is less stable compared to that of the reactant, so the transition state is more like to that of the product compared to that of the reactant. And if we calculate the halogenation reactions for the chlorination reaction, and we see that the primary hydrogen capture reaction, the value is that bond formation and bond broken energy. If we calculate, and if the value is that -8, in case of the if the Cl dot is capture the hydrogen atom at the primary position, and the Cl dot is capture hydrogen in the 3 degree position, and shows that the 3 degree hydrogen atom is more favorable. But according to the Hammond postulate, the transition state is more like to that of the product compared to that of the reactant. So the primary halogenation occurs is more preferably compared to that of the 3 degree halogenation. But in case of bromination, the case is opposite, that is 3 degree halide hydrogen abstraction is more preferable compared to that of the primary hydrogen abstraction. And this problem is come in the 2023 NET examination, and it has been shown that there are several options, but the 3 degree hydrogen captures by the bromine radicals is more preferable, and it gives the 3 option is the correct option. Now this problem is very interesting problem, and it is come from actually Clayden groups, and this message is very interesting due to that of this radical is first preliminary observed that this radical is present as a dimeric form, but in practical cases this radical is not present in the dimeric form, and it is mainly present in this form, and this has been proved by the 1970 NMR experiment. And these radicals are very stable radical. We know that the radicals are mainly unstable, but this is the examples of these radicals, and these radicals are very stable radicals in the natural conditions. Now in the next video, we will discuss about that of the NMR spectroscopy, that is the 13th NMR spectroscopy, and this problem was come in the NET 2023. I will discuss the next video. Please like this video and share this video, and share the academic students for understanding the video. I am greatly thanks to my scholar Paritosh Barik and Chandan Kumar Pal for the creation of this